followed for our system. Then final one is designing the computing platforms, general electronics architecture, program platform level performance analysis. So these are the topics and which are can be consist of first unit. So in this, so last class we have seen about complex systems and microprocessors. So now we can see about the embedded system design process. So in this unit, the CO course outcome related to the fundamental concepts, design process, and design methodologies of an embedded system. This can be under the K2 level. So the topic we are going to see is embedded system design process. So embedded system. Before going to the embedded system design process have two objectives. So one is it will give us an introduction to the various steps in embedded systems design before we develop into a more detail. The second will be a design methodology. So which kind of design methodology that we are going to follow for our system. So design methodology is important for three reasons. What is the reason for going for designing system? So one is it allows a scorecard. Scorecard in the sense it can be used to identify the performance level of a system. Then second one is it can be used to what are the technologies that can be used in our systems. So for designing a system we need CAD system, so we call it as computer aided design to develop a system. The next one is the third one is for designing, so that can be used to communicate with the system. Then so there are two types of design process. One is top-down approach and another one is bottom-up approach. Top-down design consists of, so first we have to get the requirements from the customer, then specifications, then architecture, components, and then system implementation. So these under the fall of the top-down approach. Suppose if we do the reverse process that we call it as a bottom-up approach. So most probably we do it by using top-down approach. So in this first one is requirements. So requirements in this first we have to get the details from the customer. So what they need in terms of their requirements. So creating the architecture and components. First we gather an informal description from the customers known as requirements, and we define the requirements in our system. So it can be used for our architecture. So requirements may be a functional or non-functional. So typical non-functional requirements includes how it can be used to perform its design, then cost, manufacturing cost in the sense of manufacturing cost, then physical size and weight, power consumption. So for example, if you are designing a GPS moving map, so it requires, so what are the elements that can be used to identify the GPS moving map? Second one is specification. So specification serves as the contract between the customer and the architects. So it probably can be the least familiar phase of this methodology for beginners, designers, but it is essential to create working system with a minimum of designer's effort. The specification should be understandable enough so that someone can verify that it meets system requirements and overall expectations of the customer. Then third one is architectural design. So architecture design it says how the system is going to do that. Only what the system does. So describing how the system implements the functions of the purpose by using its architecture. So the architecture is a plan for the overall structure of the system that will be used to later to design the components that make up the architecture. The creation of the architecture is the first phase of what many designers think of a design. The fourth one is designing hardware and software components. So designing the components in general include both hardware, for example FPGA boards and so on, and software modules. Some of the components will be ready-made. So you will have to design some components by yourself that can be used by yourself. The fifth one, last one is system integration. The system integration consists of combining all the system in a single manner that's all about